Hey, how you doing? This is Tom, and this is Tom's Radio Room Show. And this morning, let's see what time it's almost 7 a.m. here in Clearwater, Florida, and I'm going to try to do, excuse me, some testing of the Radio Shack multi-band antenna. This guy right here, which is supposed to be good for the whole shortwave band almost, and it's a inverted V antenna. Here's the mounting configuration right here. I've got the peak at about 12 feet. It says it should be at 20 feet. Damn, I couldn't get it up that high. And this is the basic antenna. It has two legs and then this T connector. There's no matching transformer or anything. So we're going to see if we can do some testing with that this morning. And I've got my MFJ-226 analyzer, and it's scanning from, I think, 3 megahertz to 30 megahertz. And I don't know if it's going to show up very well, so I'm going to kind of talk about what's on there. Let me see if I can hold it up. That's not too bad. So it's real-time scanning that band, that 3 to 30 megahertz band. And right now it's showing the SWR. If I can get a little closer for a second so you can look at it. And you can see it's pretty jagged as far as the SWR, and then there's a low spot way up here. It's a low spot. Let me see what that is. Let me zoom the cursor over there. Pretty high frequency. It's about 21.5 megahertz. So it's not doing too bad. I'm going to record a couple of frequencies. We're going to start with 5 megahertz. Let me go down to that. Whoops, I went past it. Oh, I'm looking at the wrong. I should be looking up here. I'm looking down here. I've got to look up here for the frequency. Oop, 6, 5, 4.9, 5.14. The SWR is 12.79, and I need a pointer here. And you can see down here it's coming down with a minimum right there. So at 5 megahertz, it's changed a little bit. It's about 12.9, I'll say. And I'll scan up here and look for that low spot. Right there, it's 3.03 megahertz at 7.2. So I'm going to say, I was going to write down 7. Let me go back to 7. There's about 7.07, and it's 3.64. Now, the thing is, what I believe is, as far as receiving, use an antenna for receiving, the SWR is not quite as important. For transmitting, it's definitely important, and you want to keep it below 2.5 for SWR. So I'm not alarmed if the SWRs for some of these frequencies is high. Now let's go to 10 megahertz. Oh, we're way past it. See how close we can get. 10.07 megahertz, and it is 12.82. Now we'll go to 15 megahertz. Trying to keep this in view of the camera, but still able to see it myself. 14.999. 14.999. It is about 15.17. Now there's another low point right there, and this is the one I showed you before. We'll stop at this one right here. So it doesn't get real low. That's at 17.6, and it's 3.4. All right, let's go up to 20. Just picked some random frequencies here. 20.14, it is 4.79. 4.79. And at 30, see if we get up that high, probably right at the end of the screen, should be 29, 30 megahertz. It's 5.97. 5.97. Okay, so it's not doing terrible. There's no extreme SWRs. So let's turn the meter off. Turn the meter off. And then we'll try my 31-foot vertical antenna. Now, the antenna is different, and the coax and the connectors are different. So we've got quite a few variables. So let me connect this up. And I believe the long wire, in-fed long wire, is tuned for 40 meters. I think that's what it's advertised at. So let's see, let's turn this on. And then we'll select sweep frequency plot. And then we'll select SWR. And let's see what's, ooh, what a difference. Look at that. That's why that antenna does so good. Look at that SWR. And so let's record some numbers. So this is the MFJ vertical. And let's go down to 5. Well, we're at 30 megahertz, and it's 3.58. We'll go backwards to 20. If I'm going the right way. Yep, I'm going the right way. I'll try to remember to hold this up to the camera so you can kind of see the readings. Okay, there's 20.14. It's down on the lower part of the curve here. So it is 1.81. Pretty good. This is a pretty good antenna. Now, this antenna, unlike the other one, does have a matching transformer. So it converts the high impedance of the long wire to 50 ohms. That's what the idea is. Now, let's go down to 15 megahertz. I got to turn the air conditioner back on. It's hot out here in my workshop. 14.999. And it's kind of high right there. It's 8.42. Most of these numbers are half what the other antenna is. So we go to 10. Whoop, I went past it. 10.07, it's 7.0. And at 7, it's 1.86. And at 5, oops, I went way past it. 5.14, it's 6.15. And there's a low over here. Let me see where that is. That is, it's 1.1 is the SWR, and it's at 7.7. Now, this antenna is supposed to be resonant. It's supposed to be resonant at the ham bands, especially the 40 meter band. The 40 meter band is 7 point something, and which is where we're at right now, and you can see it's 1.15. So that antenna is working as advertised. So let me turn this off. Serve the battery here. So in conclusion, and let me see if I can zoom in. Oh no, I'm max zoom. So let me raise it up and see if I can hold it. There are the numbers I got. Again, there's lots of variables. The MFJ is a vertical antenna. The Radio Shack antenna is a multi-band dipole antenna. It's, of course, oriented in my yard differently. And so there's a lot of variables here. But it shows, and again, I believe, this is my personal opinion, and I'm no expert, I believe as far as reception, SWR is not as important. It's important, but it's not as important. So having these high SWRs, I don't think are earth-shattering, but of course, having these lower is better. And that's why that antenna works so good. I mean, right now, that's my best antenna. One of the obvious reasons it's good is that it's 31 feet in the air at the peak. That's one reason. The other one, the Radio Shack, is only 12 feet approximately at the peak, where the V comes down like this. So I don't know if anything else I can do. If you have any comments or questions or things you want me to try, I can do a show on some of my other antennas. You saw that I have at least a dozen antennas set up right now. I've got the in-fed MFJ antenna that goes out to my front yard. I've got my Slinky antenna that goes out to my front yard. I've got, what else? I got the Radio Shack antenna, and I got the MFJ vertical antenna. I've got some other VHF, UHF antennas that I don't think you're interested in there for working satellites. So unfortunately, my rotator is not rotating anymore, so they're kind of useless. But the basic construction of this Radio Shack antenna is fairly simple. What they have, and I don't see a picture of it, is they have a wire. It's pretty much a flat cable, and it has I think 4 or 5 wires in it that are molded together. Now, where I've seen that is the old rotator antennas that required a bunch of wires to be brought down. That's what they used. They had it in a twisted configuration, or they had this flat wire. I think the flat wire like this is also used maybe in sprinkler systems. I think I've seen that. And so you've got, I don't remember if the number is 4 or 5, but you got 4 or 5 wires that are molded together like this. Of course, they're not that fat. And then what they do is they cut each of the strands, I'll call it. They cut each of the strands a different length to match the frequency. And that's how you get this coverage of all these frequencies. This shows a whole bunch of frequencies. There's not that many wires. I can see, I think there's either 4 or 5 wires. And so then they just come up, and all these tie together to a connector. And so it's a pretty simple design. Now it basically is a dipole antenna, no matching transformer. You could put one in here and that would get these SWRs down. And just it's a T connector at the top, and you one of these has a connector that you plug in this in, and then the other leg has a connector you plug in this in, so the antenna goes down like that. And then the coax connects here. So it would be interesting to see if I put a matching transformer. Let me just try one more thing. Let me try one more thing before I give it up here. Let's go back to that antenna. I guess we could have tested this antenna too, but I'm more interested in the Radio Shack antenna right now, and my video is getting kind of long. What I'm going to do, this MFJ analyzer will test a whole bunch of things, many of which I have no idea what they are. We're going to do a sweep frequency as we did before, but now, see, these are all the things you can test while the analyzer is sweeping the frequencies that you've selected. And we tested SWR. You can test impedance, resistance, reactance, return loss, phase angle, and a Smith chart. Whoa, it kind of blew me away. I still know how to read a Smith chart. So let's go check impedance. Now, the ideal impedance is 50 ohms. And that's why I was saying you really, for that type of configuration antenna, I think you need a balun to match the antenna itself to your coax cable, which is 50 hertz. So let's just see what the impedance is. So I'm going to select that. And now it's doing the analysis. And now here's a plot of the impedance from 3 megahertz to 30 megahertz. And you can see it's all over the place. And we're looking for 50 ohms. And so if I scan this up, and right about there is 47 ohms. That's at 8.5 megahertz. I go up, you don't want the resistance to be low. You want it to be 50 ohms, the impedance. So you can see, like I say, it's all over the place. So that will affect the efficiency of the antenna. Now let's see, let's go back. We selected impedance. We can select resistance, although I think with testing antennas resistance isn't as important, but I'm going to do it anyway. So now it has plotted resistance. And the resistance at the frequency we had selected before is 9 ohms. Now, one thing this is good for, to check to see if you have a short on your antenna or your cable or your connectors. Again, I don't really know. I just personally don't know the importance of resistance as far as an antenna, but you can measure that. Alrighty, I think I'm going to have to turn the air conditioner on, so I'm going to have to stop this video. If you enjoyed this video, please give me a thumbs up. Like I said before, if you want me to do some other testing, just let me know. Have a great day. Bye-bye.